Welcome back to Tech Cloud Solutions. Today, we're tackling one of the most crucial AZ-104 modules: implement and manage storage. Think you know Azure Storage? Let's test your knowledge with real exam-level questions from the 2020-25 syllabus. You have an Azure subscription that contains a virtual machine named VM1. To VM1, you plan to add a 1 terabyte data disk that meets the following requirements: provides data resiliency in the event of a data center outage, provides the lowest latency and the highest performance, ensures that no data loss occurs if a host fails. Which storage type would you recommend? The options are A, premium SSD that uses locally redundant storage, LRS; B, premium SSD that uses zone redundant storage, ZRS; C, standard SSD that uses locally redundant storage, LRS; D, standard SSD that uses zone redundant storage, ZRS. This question tests your understanding of Azure Managed Disk Performance tiers, premium versus standard SSD, and redundancy options, LRS versus ZRS. You need to match three specific requirements: data center level resiliency, highest performance, lowest latency, and host failure protection. The correct answer is premium SSD that uses zone redundant storage, ZRS. Premium SSD with zone redundant storage, ZRS, is the correct answer because it's the only option that satisfies all three requirements simultaneously. Let's examine each requirement. 1. Lowest latency and highest performance. Premium SSDs are designed specifically for high-performance, I/O-intensive workloads with significantly lower latency than standard SSDs. For a 1 terabyte disk, P30 tier, Premium SSD delivers 5,000 IOPS and 200 mega per second throughput with single-digit millisecond latencies 99.9% of the time. In contrast, standard SSD, E30 tier, provides only up to 500 IOPS and up to 100 megabytes per second throughput. That's a 10x difference in IOPS. Premium SSDs are suitable for mission-critical production applications requiring the best performance. 2. Data resiliency in the event of a data center outage. This requirement explicitly calls for protection against data center level failures, which can only be achieved with zone redundant storage, ZRS. ZRS replicates your data synchronously across 3 availability zones within an Azure region, ensuring your data remains available even if an entire data center goes offline. LRS, locally redundant storage, only replicates data within a single data center, protecting against server rack or drive failures, but not data center outages. 3. No data loss if a host fails. ZRS protects against host failures because it maintains copies across multiple physical locations, zones. If one host or even an entire zone fails, your data is still accessible from the other zones with zero data loss. Why the other options don't work? A. Premium SSD plus LRS has the performance, but LRS doesn't protect against data center outages, only single data center replication. C. Standard SSD plus LRS lacks both the required performance, 10x lower IOPS, and data center level resiliency. D. Standard SSD plus ZRS has data center resiliency but significantly lower performance than premium SSD. Quick takeaway: when you need both maximum performance and data center level resiliency, always choose premium SSD with ZRS. Premium SSD gives you the highest IOPS throughput with lowest latency, while ZRS ensures your data survives data center failures. If this video is helping you, support us by hitting the like button, and don't forget to subscribe for more content like this. You have an Azure subscription that contains the storage accounts shown in the following table. You need to identify which storage accounts support lifecycle management. What should you identify for the above requirement? The options are A. Storage 1 only, B. Storage 2 only, C. Storage 1 and Storage 3 only, D. Storage 2 and Storage 3 only, E. Storage 1, Storage 2, and Storage 3. This question tests your knowledge of which Azure storage account types support lifecycle management policies. You need to check each storage account's kind type against Microsoft's supported account types for lifecycle management. The correct answer is E. Storage 1, Storage 2, and Storage 3. All 3 storage accounts, Storage 1, Storage 2, and Storage 3, support lifecycle management. Looking at the table, Storage 1 equals Storage v2, General Purpose v2. Storage 2 equals Blob Storage. Storage 3 equals Block Blob Storage, Premium Block Blob. According to Microsoft's documentation, lifecycle management policies are supported for block blobs and append blobs in General Purpose v2, Premium Block Blob, and Blob Storage accounts. Let's verify each account type. 1. Storage v2, General Purpose v2. This is the standard recommended storage account type for most scenarios and fully supports lifecycle management for transitioning blobs between hot, cool, cold, and archive tiers. Storage 1 uses GZRS redundancy, which is also compatible with lifecycle policies. 2. Blob storage. This dedicated blob storage account type supports lifecycle management for blob data. Storage 2 uses RAGRS redundancy and can implement lifecycle policies to automatically tier or delete blobs based on access patterns. 3. Block blob storage, premium block blob. Premium block blob storage accounts support lifecycle management for block blobs and append blobs. Storage 3 uses ZRS redundancy, which works with lifecycle policies. Note that premium accounts don't support the archive tier, but they can still use lifecycle management for other operations like deletion based on age. What lifecycle management does? These policies allow you to automatically transition blobs to cooler tiers, hot, cool, cold archive, based on last modified time or access time. Automatically delete blobs at the end of their lifecycle. Define rules that run once per day at the storage account level. Apply rules to specific containers or blob name prefixes. Quick takeaway: all three major blob-capable storage account types support lifecycle management. General purpose v2, storage v2, blob storage, and block blob storage, premium block blob. The redundancy type, GZRS, RAGRS, ZRS, doesn't affect lifecycle management support. To get the free PDF or mock test, comment PDF or mock or both. I will share the downloadable link within next 24 hours. You have an Azure subscription that contains the storage accounts shown in the following table. You need to identify which storage accounts support moving data to the archive access tier. What should you identify for the above requirement? The options are A. Storage 1 only, B. Storage 2 only, C. Storage 1 and Storage 3 only, D. Storage 2 and Storage 3 only, E. Storage 1, Storage 2, and Storage 3. This question tests your understanding of Azure Archive tier support based on both storage account type and redundancy configuration. The critical detail is that Archive tier has specific redundancy requirements. Not all redundancy types support it. The correct answer is B. Storage 2 only. Only Storage 2 supports the Archive tier. The key rule from Microsoft documentation: only storage accounts that are configured for LRS, GRS, or RAGRS support moving blobs to the Archive tier. The Archive tier isn't supported for ZRS, GZRS, or RAGZRS. Let's analyze each storage account from the table. Storage 1, Storage v2 with GZRS. Kind, Storage v2, General Purpose v2, normally supports Archive tier. Redundancy, GZRS, GeoZone Redundant Storage, not supported for Archive tier. Result: cannot use Archive tier. Storage 2, Blob Storage with RAGRS, Kind Blob Storage, supports Archive tier. Redundancy, RAGRS, Read Access Geo Redundant Storage, supported for Archive tier. Result: can use Archive tier. Storage 3, Block Blob Storage with ZRS, Kind Block Blob Storage, Premium Block Blob. Premium accounts don't support Archive tier anyway. Redundancy, ZRS, Zone Redundant Storage, not supported for Archive tier. Result: cannot use Archive tier. Why this matters? The Archive tier is the most cost-effective storage option, but has the highest retrieval latency, hours, and requires minimum 180-day retention. However, Microsoft has architectural limitations. Archive tier currently only works with traditional geo-redundancy models, LRS, GRS, RAGRS, not with zone redundancy models, ZRS, GZRS, RAGZRS. Additional note: even though Storage 1 is a Storage v2 account, which normally supports all access tiers, its GZRS redundancy configuration prevents it from using Archive tier. Similarly, Storage 3 is a premium account which doesn't support Archive tier regardless of redundancy. Quick takeaway: Archive tier support depends on both account type and redundancy. Only accounts with LRS, GRS, or RAGRS redundancy can use Archive tier. Zone redundancy options, ZRS, GZRS, RAGRS, are not compatible with Archive tier. You have an Azure storage account named Storage 1. You plan to use AzCopy to copy data to Storage 1. You need to identify the storage services in Storage 1 to which you can copy the data. Which storage services should you identify? The options are A. File only, B. Blob and file only, C. File and table only, D. Blob, table, and queue only, E. Blob, file, table, and queue. This question tests your knowledge of AzCopy's capabilities and which Azure storage services it supports. Azure storage accounts can contain multiple services, blob, file, table, queue, but AzCopy doesn't support all of them. The correct answer is B. Blob and file only. AzCopy supports only blob storage and Azure Files. According to Microsoft's official documentation, AzCopy allows you to target specific storage services such as Azure Blob Storage or Azure Files. This means you can use AzCopy to copy data to and from these two services, including operations like blob to file to blob, and blob to blob transfers. What AzCopy does support: Azure Blob Storage. Upload, download, copy, and synchronize blobs between storage accounts using server-to-server APIs. Azure Files. Transfer files to or from Azure Files Shares with AzCopy v10. What AzCopy does not support: table storage. AzCopy cannot copy data to Azure Table Storage. Queue storage. AzCopy cannot copy data to Azure Queue Storage. Why this limitation exists: AzCopy is a command line utility specifically designed for high-performance file and blob data transfers using efficient server-to-server APIs. Table and queue services have different data structures and APIs. Tables store structured NoSQL data with entities and properties, while queues store messages for asynchronous processing. These services require different tools and approaches for data operations, such as Azure Storage Explorer, PowerShell cmdlets, Azure CLI, or direct REST API calls. Use cases for AzCopy. Common scenarios include copying data from on-premises to Azure storage accounts, copying between storage accounts, uploading files to blob storage, downloading blobs, and synchronizing data. AzCopy uses authorization via Microsoft Entra ID, or SAS tokens, and supports both blob and file endpoints. Quick takeaway: AzCopy equals blob and file services only. For table or queue operations, you'll need different tools like Azure Storage Explorer, PowerShell, or Azure CLI. You have an Azure storage account that contains 5,000 blobs accessed by multiple users. You need to ensure that the users can view only specific blobs based on blob index tags. What should you include in the solution? The options are A, a stored access policy; B, a role assignment condition; C, just-in-time VM access; D, a shared access signature, SAS. This question tests your knowledge of Azure Attribute-Based Access Control, ABAC, and how to restrict blob access based on blob index tags. The key requirement is that users should see only specific blobs matching certain tag values, not all blobs. This requires conditional access based on tag attributes. The correct answer is B, a role assignment condition. Role assignment conditions using Azure Attribute-Based Access Control, AB, are the correct solution for filtering blob access based on blob index tags. Based on the information gathered, you can allow read access to blobs based on blob index tags and custom security attributes by using Attribute-Based Access Control, ABAC, conditions by adding conditions to role assignments. Here's how it works. You assign users an Azure RBAC role, like Storage Blob Data Reader, but with an additional condition that checks whether the user's custom security attributes match the blob's index tags. For example, if user Brenda has attribute project equals Baker, she can only read blobs with the project Baker blob index tag. Similarly, user Chandra with project equals Cascade can only read blobs tagged project equals Cascade. This approach provides fine-grained tag-based access control for 5,000 blobs without creating individual permissions for each blob. Why the other options don't work. A, stored access policy. These define constraints for SAS tokens, expiration, permissions, but cannot filter access based on blob index tag values. C, JIT-VM access. This is for securing virtual machine access via Azure Security Center, completely unrelated to blob storage. D, shared access signature, SAS. While SAS tokens can include permissions to access blob tags, they grant broad access and cannot conditionally restrict which blobs users see based on matching specific tag values. Quick takeaway: for tag-based blob filtering at scale, use role assignment conditions with ABAC. This lets you write conditional logic that compares user attributes to blob index tags, ensuring users only see blobs they're authorized to access based on tag matching rules. If these storage questions boosted your confidence, hit like and subscribe. Next up is Monitoring and Backup Management module. Comment your score below and see you in next video.